Welcome to Mathematics with Tom. I am Tom, and today we're going to take a look at solving a second-order linear differential equation using the variation of parameters. So here we go. So this is what we've done. We've solved a y double prime plus b times y prime plus c times y equals some forcing function. We've looked at a few, mostly variations of undetermined coefficients. Now we're going to try something new, and here's what this is. Suppose A, B, C are functions of t, are functions of t. In other words, the differential equation would really look something like this. A of t y double prime plus b of t y prime plus c of t y equals f of t. Okay, and then we're going to solve that, but we're actually going to make it a little easier on ourselves. Notice that a of t has to be not 0. If a of t is 0, well, we don't have a second order differential equation to solve. So I'm just going to divide this entire equation through by a, and I'm not going to change the b of t or the c of t to another letter, but it would just be b of t divided by a of t. And it would just be some new function. So in other words, really what we're going to work on is y double prime plus some, I'll write it this way, b tilde of t because we divided by a, y prime plus, we'll call it c tilde because we divided by a, y equals some f, we'll call it f tilde because we divided by a. Okay, here we go. Let's solve this. Well, the key to this, there's one caveat, and the caveat is this: the null solution must be known. Okay, so we're going to say, suppose y null is, and it's just going to be like we'd expect. We'd have two solutions. We'd have c1 times our first solution, often like an e to the s1t. So we'll just call it y1 of t. And I'm going to put, I won't write the t, just y1 plus I'll have some c2 times my second function of t, y2. And then what we do is this, is now we revise this. Revise, if I could spell revise, so that we're going to try, it's still a variation of the null solution. It's going, I'm just going to call it y, or we could even call it y particular. But notice it's just the null solution, but now c, the constants are functions. y1 plus c2 of t y2. And we're going to use this notation interchangeably. So from now on, whenever we're talking about c1 and c2, those can be functions of t. And this, if this is the null equation, that means it has to solve the null equation where y double prime plus b of t y prime plus c of t y equals f of, or equals 0. So let's do that. Let's solve this, and it proceeds in a probably a very expected way, but we take a few unique turns along the route. So let's start by finding y particular prime. Well, that's going to be the first, so I'm not going to write the of t, so we'll just call it c1 times the derivative of the second, so that's y1 prime, plus the derivative of the first, c1 prime times the second, y1, plus, and now we do this on the second term, so that's going to be a c2 y2 prime plus c2 prime y2. And what we do now is we don't want to take a derivative of y particular prime with these c primes in here. So what we do is we say, okay, let's let c1 prime y1 plus c2 prime y2 equal 0. And we're going to actually call that equation 2. That's what our author is calling it. So we'll call it equation 2. Well, now I can rewrite my y particular. My y particular now is just c1 y1 prime, not double prime, prime, plus c2 y2 prime. And now we can continue. So let's find y particular, oops, that was prime. Double prime is, we apply the product rule. So it's the first, c1, times the derivative of the second, that's y1 double prime, plus the derivative of the first, c1 prime, y1 prime, plus now we're on the second term of c2 y2 prime. So that's c2 y2 double prime plus what? C2 prime y2 prime. There we go. And now, here's the best part. We substitute into y double prime plus b tilde of t y prime plus c tilde t y equals f tilde of t. Substituting into that. All right, here we go. So this is c1, and I'll put it in parentheses, y1 double prime plus c1 prime y1 prime plus c2 y2 double prime plus c2 prime y2 prime plus, then we're going to have our b, I'm just going to write it from now on, just b tilde on y particular prime, that's c1 y1 prime plus c2 y2 prime plus, then I have my c constant or function times y particular, which is also just a variation of y null. Well, that is c1 y1 plus c2 y2, and this all has to give me f tilde. Now, this is where this may not be obvious initially, but if you look closely and you have a red pen like this one, notice that c1 y1 double prime plus b times c1 y1 prime plus c times c1 y, oops, I forgot a 1 on that one, y1, that is the null equation. That is what this solves. That's 0. And if you have a blue pen, well, then you'd see that you have a c2 y2 prime plus you have a b times c2 y2 prime plus you have a c times a c2 y2. Well, those also solve. Actually, let me write it this way. The red one is solved by this first term. The red one is solved by that first term. And the second one here, the second one is solved by the second term of the null equation. So those are just zeros. Well, what do I have left? That means that I have a c1 prime, y1 prime, plus I have a c2 prime, y2 prime, and that equals your function f tilde. And there we are. Oh, wow. Now, we'll use the same notation as our book. This, we're going to call this equation 1. So let's see what we have. I'm going to write, here's equation 1. I'm going to write equation 2 right below it. c1 prime y1 plus c2 prime y2 equals 0. And now what we're after is what is C1 and what is C2. So let's solve this. So I'm going to solve this first off. This is equation 2. So this is going to be a little tricky here. So let's solve this by, we're going to have to multiply equation 1 by y1 and equation 2 by y1 prime. And then if we do that, well, let's write that out. What is that? That's going to be, I'm going to come to a new page. I can tell this is going to be a space hog. So let's do this. Copy this. I'm going to turn this into, I'm going to take a y1 and multiply it by equation 1. We'll do it, yeah, positive. So let's see what we get. So this is a C1 prime, y1 prime, y1 plus C2 prime, y2 prime, y1 equals f tilde y1. And then let's take a minus y1 prime times equation 2. So that's going to be a minus C1 prime, y1 prime, y1 minus C2 prime, and then we're going to pick up a y2 y1 prime, and that's still going to be 0. And now let's just add these two rows together, and notice that the first two terms drop out, and so I get a C2 prime, y2 prime, y1 minus C2 prime, y2 y1 prime equals f tilde y1. Just adding those together. And so now look at what we can say. Now we can say, if I factor, let's factor out a C2 prime. That's going to give me y2 prime y1 minus y2 y1 prime equals f tilde y1. So I can say that C2 prime is equal to f tilde times y1 divided by, oops, that looks kind of squished here. C2 prime is equal to f tilde y1 divided by this whole quantity of y2 prime, y1 minus y2, y1 prime. Oh my gosh, we're almost done. That's it. We've really solved the whole problem, but it may not be apparent yet. And that is because, notice we have a denominator in our problem. This denominator, this is a special denominator. We'll come back to it in a little bit. But I'm going to call it W, and the W is for a name. This whole denominator is called W, and it stands for what's called the Wronskian. So I'll underline it, W-R-O-N-S-K, Wronskian. Okay, so from now on, I'm just going to write, well, when I get tired of it, I'll probably just write W. So, but now we can find C2, because C2 is very simply the integral of f tilde y1 over w dt. There we got it. There's C2. And now I can use all of this to go back and find C1 as well. So let's do that. Let's substitute that back into equation 2. It just looks easier because we have a 0. So we're going to use equation 2 here. That's going to be C1 prime y1 plus, now we're going to copy our C2 prime. That's going to be f tilde y, f tilde y1 over, I'm going to write out the w, y, I'm going to save the w for a moment, times y2. This is equal to 0. And then let's move these over. So now I have that c1 prime y1 is equal to f tilde y1 y. Oops, I wrote y squared. It's not y squared. It's y. It's y2. y2. And then all of that is over w. I can divide both sides by y1, and so look at what we've got. We've got that c1 prime is equal to f tilde y2 over that same value of w again. And now we've done it. Our problem has been solved because now c1 is just the integral of f tilde y2 over w dt. And our final solution now, our particular solution, is equal to c1, so it's the times y1 of t. So I'm going to write it this way, y1 of t times c1. Well, c1 is this. It's this, the integral of f tilde. Oh, I did it again. I wrote a 2 instead of a y2. There. y2 over w dt plus y2 of t times c2. Well, c2 is the integral of f tilde y1 over w times dt. And there you have it. We have just solved the problem. And the last bit I wanted to show you is what the Wronskian is. So the Wronskian is defined as the determinant of the solutions and their appropriate derivatives. So if it's a second order equation, you're going to take a first up to a first derivative. If it's a third order differential equation, you'd take up to the second derivative. And so it's the solution and their derivative. So our first solution we said was y1. Our second solution is our second solution is y2. And then in the same columns we take their derivatives, y1 prime, y2 prime. And here's what happens. If we take the determinant, now that's a new term for you. The determinant says you multiply from the top left down to the bottom right, and then you record that result. So that is going to be y1, y2 prime, y1, y2 prime. And then if you have red, then you start from the bottom left and you multiply up to the top right, and you subtract that quantity, minus y1 prime y2. And as long as this is not 0, as long as the answer is not 0, then the solutions are said to be linearly independent. Linearly independent. If they equal 0, obviously, if the Wronskian is 0, then there's nothing to solve because you'd be taking the integral of something that's undefined. So it's a quick check, maybe before you launch into a problem later, only to find that your denominator becomes 0. And that is how we solve a problem using, or that's the idea behind variation of parameters. In our next video, we're going to take a look at using it in an example. I hope that helps, and thanks for watching.